Hello, everyone, and thank you so much for joining us today. I am proud to feature the GitLab 13.0 release technical showcase. Big things happening. So I've got the agenda in the chat, and we've got an exciting lineup today. So Simon and Christian are going to talk to us about Gitaly and is it Praefect? Am I saying that right?
Yep.
Chloe's going to talk about new defend features with standalone vulnerabilities and exportable vulnerabilities. Mark is going to talk about the AWS ECS Auto DevOps feature. And Jamie's going to take us home with the TF plan view in MR and HTTP Terraform Slate backend. So Simon and Christian, the stage is yours.
All right, Simon, I can share my screen if that works for you.
Yep, that's fine. Go for it.
Cool. So this is a pretty highly anticipated capability we've been talking about for probably over a year for many of us with customers, because when we talk about setting up GitLab in an HA configuration, the one caveat we've always had to put on it is they accept Gitaly, which isn't actually HA capable yet, and you have to use NFS, and it becomes a little bit of an annoying asterisk. But with GitLab 13, we have finally released our first iteration of what we're calling Gitaly Cluster, which is our HA solution for that. Essentially what this is it is a high availability solution for Gitaly, and allows for you to build out scalable and redundant repository storage and negates the need for NFS. So with this, we have now gotten to the point where you can deploy GitLab without any NFS behind it at all. And
there is one asterisk there, which is actually pages support. I was about to say, yeah,
okay,
but not for GitLab.
But that's not a
pages.
mandate. There's other ways to deploy pages that allow you to get into that. But we'll
and also you don't normally have the same performance concerns that you do with pages as you do with Gitaly. So yeah. Right.
So fair point. Yes, there is that asterisk, but yes, for an HA environment now, you technically don't need NFS really at all. Depending on how you set it up, but especially not for your Git repositories, which is the key thing here. And so this basically addresses the last remaining single point of failure element of GitLab. So this is a big thing for customers who are running in cloud providers, on-prem, what have you, because this also means that they can leverage any number of storage volume solutions behind their Gitaly instances in whatever works best for their environment, and allows them to scale in a variety of different ways. So here's the architecture from our documentation that describes what it looks like when you set up a high availability Gitaly environment. So you'll note here the bottom half of this outlines what it looks like. And so there's a few key elements here that we're going to talk through here in a moment. But you'll see that essentially the ingress point for the Gitaly cluster is a load balancer in this architecture. The reason for that is that Praefect can actually have multiple Praefect nodes in a cluster so that you can even remove the single point of failure of your Praefect component in your cluster. So it can communicate with your, in any combination with the Postgres database that is set up for Praefect, and act as a load balancer itself and handle any request. So it's not a requirement to have a load balanced Praefect environment. You can have just a direct connection from your GitLab instance to a single Praefect node. It's up to you, but it is architected to allow you to do it in a way that even Praefect is redundant. So, and then you'll notice here the actual Gitaly nodes, they're set up in clustered groups, and you can also shard across multiple Gitaly instances behind Praefect if you needed to do so. For example, your storage volumes can't support a horizontally scalable Gitaly environment for IOPS purposes, and you need to have multiple different physical storage volumes behind it. There are use cases there. It gets complicated, but it can be done. So the idea here is that this provides a variety of permutations for setting up an HA environment for your Gitaly storage. So Praefect specifically, we've mentioned this a few times, and Simon, I know I keep talking here. I'll let you carry this one if you want to discuss this one.
Yeah, no, I mean, most of it's already been said. So like Praefect is this sort of thing that sits in front of Gitaly. It's sort of transparent to GitLab. GitLab doesn't know that it's talking to Praefect. But it's the thing that's responsible for syncing all the Gitaly nodes, and it's the thing that's responsible for really implementing the HA. as Christiaan said, you can have multiple Praefect nodes so that the Praefect node itself isn't a single point of failure. And yeah, really, and it also does some load balancing as well. So the Praefect nodes also kind of have this kind of element of balancing traffic between the various Gitaly nodes as well. So yeah, that's really what Praefect is. You will hear it mentioned a lot if you're talking about Gitaly cluster.
Yeah, it is of note. This is a new element that our Gitaly team developed specifically for this purpose. So it is likely from now on that you're going to hear Gitaly and Praefect said in the same breath for most occasions. Anything outside of the omnibus package, you're probably going to hear this referred to quite a bit. So Simon and I on Monday actually went through the process of setting up a Gitaly cluster, and we started from an existing environment that I created with a single Gitaly app, or a GitLab app node, and a Gitaly node separately configured. We took this approach figuring that the majority of our customers currently looking to do this probably have some variety of HA architecture where they've broken out the various components that GitLab uses onto different nodes for scalability, and there's a good chance that Gitaly is a standalone element as part of that. So I wanted to replicate roughly what you'd likely encounter when you're dealing with an existing environment with Gitaly for prospective HA configuration. And so we went through the process of building out the Gitaly cluster, integrating it into GitLab, and then figuring out how you would migrate data from your existing Gitaly space to the new cluster. We won't take you through the multi-hour process in depth. If you really are interested in doing that, you can watch the video that we put on YouTube Unfiltered, which I pared down a few spots where we fumbled through GCP for our own lack of knowledge there and eventually figured out the solutions. But you can see the progression from start to finish of how we got that done, and some pitfalls we encountered. But here are some of the takeaways from going through that process. Simon, I don't know if you want to go through some of these. I'll let you.
Yeah, so something to be aware of at the moment is that the Praefect leader election is currently it favors availability over consistency. So that at the moment there is a possibility of data loss. And it's very unlikely. It's when a Praefect node has to fail and basically the leader election it takes place. There is an issue that's in flight at the moment to change that to default to using the Postgres database that Praefect uses to do leader election, and that's going to be made the default in 13.1. It's actually there now. It's just not the default. I think it's because it was still untested when it was launched. So that will give you consistency over the availability and kind of solve those issues. The next point I added, so I'll talk about it, which is that at the moment, when you install Omnibus, you kind of get everything all in one, and you get a Postgres database there for all the data as well. Omnibus does not include a Postgres database for Praefect. Praefect needs its own database, ideally. It can actually go inside, and this is another point of it later on. It can go inside your GitHub database, but it's not supported in that configuration when you're using Geo. So for that reason, I mean, myself and Christiaan would both recommend, I think, that you separate it out straight away, because if you ever want to go to Geo, you then have to untangle your database. So there's no Praefect database going to be installed in Omnibus by default at the moment. Do you want to take the next one, Christiaan?
Sure. So as I mentioned earlier, one of the things that we went through in our setup process was the effort to migrate data from the existing Gitaly instance to the Gitaly cluster. When you create the cluster, you have to go into your GitLab RB file and add that as a data directory that GitLab can use to store information. But all storage volumes are created equal in GitLab's eyes, so you have to tell GitLab where you want projects to be stored. And to migrate from an existing one to a new one requires API calls. Right now, I don't know of any utility that has been created to help support the migration of data in a batch process from one location to another. I actually have started poking myself at just building a proof of concept that might be able to do that as a very simple CLI, just as a personal project to maybe facilitate that more easily. We'll see what comes out of that and if it's really usable. But it is something that right now you do have to script via API calls to migrate from one to the other. Yeah.
The next one is really, I've already said, which is separate your databases out. And then the final point is that at the moment, there's very limited scope for admins to actually be able to monitor the cluster. There's an epic around this. This is something that the Gitaly team is working on. And so, yeah, that's something that they're really pushing for. So,
well, one final point I wanted to make on that first bullet here. The main reason for this is if you're not familiar with clustered environments and data consistency architectures and stuff like that for this type of thing, the main reason that there's a potential for data loss with the way it's currently set up is if your primary Gitaly node fails, what Praefect does right now is it just picks another one. It doesn't worry about how up to date it is. It just picks one and uses that as the leader, and then it goes forward from there. The database that gets created for Praefect is also used to track the changes that occurred over time and which nodes have which data sets, but it's not currently utilizing any of that information to actually pick the leader. So there is a possibility if you get out of sync that it will say, we don't know which nodes have what, and it'll put you in a read-only state for any repositories that don't have up-to-date synchronization. So that's the reason behind that, is that they're working on that in 13.1. Hopefully we'll see resolution to that point. It won't even be a concern by the time our customers are deploying this in production.
Okay. Yeah, so we went into this process without having read up anything, without having spoken to the product team about it specifically. So we do it as if a customer was running through the process. We did make notes throughout the process, and we followed the documentation. And actually, the documentation is really solid. There was pretty much only one point really where we really truly got blocked, and that was due to the cloud provider documentation really, rather than our own. But we're going to add those, everything that we've got feedback for, we're going to add back into the Gitaly team and try and get that added to the docs. One point of note is that the reference architectures, so the 5, 10, 25, and 50K architectures, do not yet have Gitaly cluster in the reference architectures. That is something that people are aware of, and they're adding that support.
I made a note here at the bottom that the GitLab Orchestrator project, this is something that I actually was made aware of by Jason Plum when he graciously joined our session on Monday to try to help us work through some GCP issues. We apparently have a project underway at the moment that some engineers are working on to build out basically a canonical set of Terraform and Ansible scripts that customers could use to set up GitLab in any permutation of single omnibus install up through full HA capability. And they're building in the ability to build out Gitaly cluster as part of a scripting process. I will update the deck here with a link to that project if you're curious. Jason gave us all sorts of disclaimers about this is not production ready, this is not productized yet, your mileage may vary, customers can use it, but it's up to them how they do it, all that kind of stuff. But it could be a very useful resource for any customers that you're working with that are interested in having any sort of infrastructure as code configuration and are looking to us to provide some guidance or best practices on how to do so. Because it looks like it's pretty well-rounded right now as to all the components that it covers. So it's something worth looking at as an aside if you're interested. So the main takeaways from this, from going through the exercise that Simon and I did and reading through the docs, is that Gitaly cluster is really well architected. It's clearly thought out to be scalable and redundant and address all the concerns that somebody would have with building an HA solution, especially when you're dealing with the types of things that Git transactions cause with storage. So I think it's going to be a great solution. Obviously, there's a few limitations right now that I would say make it a little premature to implement in a production environment. I've been giving my customers guidance before this was even released that they should probably hold off until probably 13.1, 13.2 until they look at doing this in their actual production environments, just anticipating that since it was the first GA release, there were naturally going to be bugs that got surfaced by it being out in the wild. And that aligns with what we've been seeing from some of the known caveats to it that they're expecting to resolve in the next couple of releases. So I've encouraged customers to set this up in staging environments to test it out and understand the process, but I would say it's probably not production ready for most of them until later this summer. And as you know, Simon and I have also agreed that we're going to help the Gitaly team develop the docs to be more, even more usable than they already currently are for a customer-facing perspective, so that ideally customers can walk through this step by step with little to no assistance from us.
Hey, Christian, aren't we using this in production today or no on GitLab.com?
We may be using it in production on GitLab.com, but let's not forget we also run some beta releases of the product itself on GitLab.com. So I think we're more risk tolerant with our dedicated infrastructure team to do so. And we probably have it built out in such a way that we're limiting the risk of data loss because of the scale that we're probably putting it at. That would be my assumption. But yes, I do believe we are using it in production.
And one of the biggest things is the leader election, which, as I said, is not defaulted to switched on, but it is available. So I imagine that our infrastructure team have probably switched that on. So yeah, that would be the main thing.
But from the perspective of, customers who have more limited resources for this type of thing than we do, I've generally recommended to them, just give it a couple of months so this thing stabilizes and gets to fully production ready for you.
Mark, you actually had a really good question, which I think is worth calling out. It's a pretty challenging question to answer. So, and I know we don't have too much time, so I'll just be quick. But you sort of said, does it cost more or less than the traditional NFS model?
Probably going to cost more, to be honest.
How much more?
So, I mean,
and why?
Basically, well, all right. So here's why. In a traditional NFS model, you probably have some combination of a compute instance and a storage volume to support your NFS, right? And that compute instance may or may not even be present. If you're not needing a managed NFS to run a compute instance, it might be provided by your cloud provider, or you may have a SAN or something in your infrastructure. But in general, you're probably going to have one Gitaly node that is connected to that storage volume for NFS. And if you have multiple Gitaly nodes that are talking to that, it's still just those nodes. In a Gitaly cluster environment, you necessarily are adding, in addition to your n number of Gitaly nodes, you're now adding at least one Praefect node, at least one Postgres database, which is probably on its own node as well, and possibly a load balancer in front of all of that between your Gitaly environment. So your compute resources alone are likely to be higher. You may see some savings if you're not having to use a managed NFS solution, but it's not necessarily going to be enough to offset the additional cost of setting up this infrastructure. With that being said, I mean, our reference architectures don't even start talking about HA until you're at like 3,000 or 5,000 users. So it may be a negligible difference from the perspective of the service provider, service provider in terms of like the group at your customer that's managing it. But just based on the architecture that we have recommended, you're likely going to be using more compute resources than you would if you were doing just a single Gitaly instance with NFS, or multiple instances even.
But one would also expect that one would gain some amount of additional performance out of this, because NFS is, pretty much a pig with regard to locking and everything else, and has its own.
Absolutely.
So
the benefits of this is that the actual implementation of your Gitaly nodes becomes much more important, because Gitaly, if it's talking to NFS, it's more about the NFS storage and how performant that is than the Gitaly node itself. Now you've got local SSDs attached to your Gitaly nodes, and that is where it's getting the data from. So potentially there is performance benefits there.
I would argue maybe holistically, when you factor in not just the infrastructure costs, but also the increased productivity from faster performance, as well as hopefully the lower amount of infrastructure management that maybe would have to take place for fine tuning your Gitaly instances to talk to an NFS solution, you might overall see a total cost reduction from that perspective, but purely from the bill that you pay to your cloud provider, it's probably going to be a little higher.
Yep. So Simon, any data on the performance we can share yet, or no? Improvement?
Performance-wise, I think it's too early to say at the moment. Okay. I think we were really looking at this from an implementation perspective, not a performance. But I can get in touch with the Gitaly team, and we can ask them if they've got any data on that.
I think they've been running benchmarks, but I don't know if they've published those yet.
Yeah, I haven't seen them. Okay.
All right, just
cool. Yeah, I was just saying, I know we're done here with ours. We're probably over time, so we'll hand it over to Chloe next. I think she's next, right?
Reb, I know you've got questions. We'll do the async, I guess.
We do have a couple minutes if we want to try to take a swipe at a couple of them. Reb, do you have a preference on which one they?
Yeah, I just say, I mean, the most important is, like, in the past, we had to have people copy data in other ways. Does this copy everything, including LFS data, which was notoriously absent from some of these things before?
I got to know totally the docs on that, but essentially, if it lives in Gitaly, it will be replicated by this, is my understanding.
I'm not sure the LFS stuff is.
I mean, my issue is that we have, a lot of people use LFS because that's a smart way of managing the size of your Git repos, and we have historically, to my understanding, not done anything except say, it's here now, you get to replicate it all over. So. Okay. Just questioning, not accusing.
Yeah, to be honest, I'm not positive how that works.
Yeah, my understanding is the LFS is stored elsewhere, so I don't think it would be classed under this. It'd be in S3 or whichever storage mechanism you're using under the hood.
Right. And I think that probably would still be our recommendation, is to use something like S3 for LFS, just because.
In which case, it would sort of magically get there through the magic of radio, as they say.
Right.
Yeah, effectively, I think what happens with LFS is there's a link to the LFS stored in Gitaly, in terms of like, this file exists in your Git repo, but it's not actually here. It's stored here.
More or less a pointer.
So that would be replicated, but the file itself would not be.
Right. I mean, that's how LFS works, because we want to keep the stuff out of the repo. But then the question is, like, what do we do with like that and pages and other data that sort of exists outside of the sort of normal Git infrastructure, like stuff that's alone in the file system? So we still have the same problem with that we did before, I guess.
Well, and the majority of that other type of data, still, we already have architectural support for using things like object storage to make it so that you don't rely on single point of failure storage solutions, and you are on a scalable option. Obviously, that doesn't work for people who are entirely on-prem and don't have an object storage layer that they can use. But our application architecture does support the use of things like S3 for all those other components. What this is targeting is specifically the components that can't live in S3 that they currently rely on NFS because there is no other solution.
Absolutely.
Namely the Git repositories. And that's where we see the most problem when people are using NFS, because of the transactional nature of Git.
Yep.
Cool. Thank you, Simon and Christian. Chloe, you are up next.
Awesome. Thank you. Okay, you can see my screen?
Yes.
Cool. So I am excited to talk about the new Defend features. Defend became a stage last year, but up until a few months ago, we didn't have any features. But this release, we got 3, which is awesome. So I hope you feel very defended. There we go. Okay, so number 1, it made the highlights for the release is standalone vulnerabilities. So what is it? Standalone vulnerabilities are also known as first-class vulnerabilities, but for our purposes, it just means that each vulnerability has its own standalone breach, which you can access by clicking on the vulnerability in the security dashboard, and then which you can link to share it or work on it, etc. On the vulnerability page, the default status for a vulnerability is detected, but you can change it to confirmed, dismissed, or resolved to keep it up to date. You can also create a new issue, which is confidential by default, and is pre-populated with information from the vulnerability report. And then finally, on the standalone page, you can apply an automatically generated solution, some of which will be manual things you have to do, and some which GitLab can solve for you, which is pretty cool. And in the example here, it's just a manual solution where I have to update the version. So this is what the standalone page looks like, and it's pretty simple. So you might be thinking like, this isn't a big deal, but it was a 1.5 year long effort to just completely re-architect our backend on how we manage vulnerabilities. So it's a low impact today, but a really big impact going forward for our vulnerability management. Each vulnerability can be triaged and tracked as the single source of truth, and they will also be persistent, what that means is that previously any new scans that were on the same branch as a previous scan would overwrite the previous findings, and now they don't. So that's less duplicates and better tracking, which is great. It also ties straight to reporting and being able to track trends, which is a big deal in Ultimate. Still, you might think maybe that's still not that big of a deal, but in true GitLab fashion, it's a MVC that will improve a ton going forward. So I linked an issue here that you can take a look at that just collects a bunch of other issues that it's going to help resolve going forward, primarily just around having a better security dashboard and more accurate vulnerabilities. So we'll have better reporting. It opens a door for a lot of potential new features, like better false positive management, having vulnerabilities linked to occurrences one-to-many, linking vulnerabilities to existing issues. None of these are guaranteed, but they're just examples of things that the team is thinking of. Now that standalone vulnerabilities exist, we can do a whole bunch more. As I mentioned, this was a huge effort, so here's some links and videos that go into more detail. The category direction page here was just updated 2 days ago, so it's super fresh. It's got dice in the mirror. It's awesome. All right, let's move on to exportable security reports, which happen to be one of the features that standalone vulnerabilities made possible. It's already making our lives better. It's great. Okay, so I personally feel very passionately about this feature because I opened the initial issue. I was involved in it every step of the way over the past 8 months, and it's finally here. It's like my baby. So before today, vulnerabilities were only exportable as a JSON, which is pretty cumbersome by itself, let alone if you want to turn it into a usable or shareable report. Much to the dismay of my customer, the JSON file showed dismissed vulnerabilities with no indication that they were dismissed. So their clients were freaking out. There was a ton of unnecessary back and forth. It wasn't a good experience. But now it's okay. You can just click a button on the security dashboard and export all of the vulnerabilities to a CSV file, and it has all the info you need. It's available on both the project and instance level dashboards, and the group level dashboard is planned for 13.1, so in a couple weeks. There's a list here of what the fields are populated in the CSV, and the ability to export PDFs is planned for next year after vulnerability management becomes viable. It's minimal right now. And if you're paying attention, that epic was linked 2 slides ago. I also noticed some gotchas here just about using the export, but overall it's pretty straightforward. It's just a button. Here are some documentation and resources, as well as a screenshot of what this super cool button looks like. All right, on to the last defend feature in 13.0, the WAF SIEM integration. So that's a lot of acronyms, not very messy foo, so let's break it down. WAF is Web Application Firewall, which filters and monitors HTTP traffic between a web application and the internet. It's a type of reverse proxy, so it protects the server from exposure by having clients pass through the WAF before reaching the server. Easy enough. The SIEM means Security Information and Event Management, so really more like an SIAM or whatever. And it's the software solution that aggregates and analyzes activity from different resources across your infrastructure. Some example providers are Splunk Security, IBM, QRadar, and Sumo Logic. So before we had this integration, there was a lack of visibility into the traffic that passes through the WAF and no real easy way to determine if it was working as expected. And nearly all users who use WAF also use a SIEM. So we figured, let's let them connect the two. So now they can monitor the WAF to review anomalies and fine-tune the rules to reduce false positives. False positives is a big theme in Defend. This is all done via FluentD, which is an open source data collector. And it just runs on each pod and allows customers to send the logs anywhere they like, so they can use whatever tool they want. The integration is available for all tiers, even the free version, and it can be enabled and configured by going to FluentD under Applications on the Operations Kubernetes page. You'll need to enter the host, port, and protocol where the WAF logs will be sent, and then select one of the available logs. That's all I got. Lots of small iterations, making a big impact, building up our Defend stage. I know we're really short on time, but does anyone have any questions?
I'll just voice mine and type it out to the doc later. Can audit events, like instance level audit events, be imported into the SIEM?
I don't think so, but I can double check on that.
Cool. Thank you. I'll look into it as well.
Any other questions on these features? All right.
Cool.
Moving right along, Mark, you're up with AWS ECS Auto DevOps.
All right, let me share here. Oops, don't want to do that. All right, can everybody see my slide or no?
Looks good, Mark.
Looks good? Okay, great. I want to notice that the picture over there is mid-April, and that's snow, and it didn't go away till the second week of May. And I actually had to shovel in May. So that's, you know, there's a moral there somewhere. Okay.
Where do you live, Mark?
I live up in Golden, but it's actually about 8,800 feet up.
Oh, wow.
Yeah, the views are unbelievable. Okay, so, and that's a plus, I think. Okay, I'm just going to go through this auto deploy to ECS. This is the first iteration, so be kind. I would not venture off with customers, but we do have the AWS Summit coming up June 17th, so GitLab magic may happen in the next 14 days. I don't know. And you'll see why. A lot of moving parts here. So I'll go through what is ECS, AWS ECS, and we'll talk about how it works, what you need to know, and then an actual live demo. How's that? All in 10 minutes. Okay. So this is AWS, you know, I guess reply to Google Kubernetes. 2015 it came out, so it's been around for a while and integrates with everything AWS. And that's one of the cons. It's AWS only, closed source. Supposedly it's quick learning, ease of use. Wow. And that is not true, as you'll find out. So there's a lot of moving parts, from cluster services, task definition, to EC2 instance, to container, to VPC, to ALB target group. We have to know all of that to put this together. But it does work somewhat. All right, how does it work? So basically you create a task definition. This is this TD. And this task definition is go and get the resources. You add an EC2 instance. It'll spin one up for it if you want, or you can do your own. Then you add a container to that. So you're gonna have to have a container, Docker container you can provide. Then you create this cluster, and this is where you take that EC2 instance with the task definition, and then you add the VPC and the subnets, right? Step 2. And 3, you create a service. This is kind of like the Kubernetes, where it actually will, you know, keep on working to maintain whatever you define. So this is where it's for keeping the number of tasks and everything running. So this is where you configure the EC2 instance. This is where you have to define the ports and everything, and you have to have an ALB. If you try to use classic load balancer, it's going to bounce you over to Fargate. So you're basically stuck with an ALB if you want to use EC2. All right. Then on our side, so now you flip over to GitLab to actually work with this. Once you set all this up, then you can go over here and you can start defining these variables, environment variables. The key one is this platform. We'll look at Auto DevOps platform target. If you put ECS in this, this is where Auto DevOps kick in. This is where you can use Auto DevOps with this ECS. You'll notice you'll need this cluster that we define over here. You'll need the service that we define over here, and you'll need this task definition. Got it? And finally, there's a nice little video. I've been working with Etienne to figure this out. He's a main contact to help make this a reality, because there's some changes they'll have to do. It took us a while to get this going. Working with Cesario too in product marketing, which I think he's involved with this AWS Summit. Any questions, or should we wait? None, will go on. Okay, one, there is no framework yet. I think we're gonna have to, GitLab's gonna have to make that commitment. There is no review apps. If you want to do that, it's all manually. So if you run this, it'll wipe out your ECS container you have in that service. So right now, I got the joy of working with ATN. It's great to working with them, but we're just not, it's not mature enough yet. If you have a Kubernetes instance and even though you set the target to ECS, it's still going to use Kubernetes. So I had to go get a separate instance, totally no Kubernetes to make, so I could work on this. So it'll override that. And these are some key links. What's really helped was an external blog that actually walked through how to set up an ECS cluster. Not for the faint of heart, but it will work. And we're putting in all the documentation, hopefully, and the team has really been great. Jason, it's been quite a bit. I mean, I think they realize it's way less mature than they need right now. Any questions before you look at it live? You guys good? Anybody run into this with a customer yet? Okay, I know I haven't. All right, so let's go to this project that I did have one here, but it never actually worked. So I worked with A10 to make this work. Everybody see this? So this is a Rails minimal app that he had to build from scratch. You'll notice there's no GitLab, dash that YAML file. So we are using Auto DevOps. And if you go down here and you look at the, what do you want to call it? The, I'm not logged in. Let me go back. Let me see if I can hit this guy now. I can get to that. Where is he? Oh, shoot. Let me go to my Slack. Now I lost him. And pick up this project. I should have had it queued up. We can do this.
Okay, we've all been there. We know what it is.
It's ugly, huh? All right, I'm here again. So we're back. I now have mine. Okay, now I can actually do something. So I want to show you the CI/CD because this is important, the settings here. And if we go into variables here, and these are the ones that we're talking about. So this is that ECS target. If you do not have this, you're not going to get the Auto DevOps. You're going to have your own YAML file and do the includes. And then these guys are the connections to the service, the cluster definition. And within that, you got to be careful with the ports to make all this work. And we're documenting that. We're in the process. And ATN and their team are working on that right now. So what'll happen is that pipeline is not that pretty, so I have to work on this. But this is the pipeline that is using Auto DevOps. So it spins up a build, auto detects that it's a Rails, and it creates this build, which is, you would expect. And the only other thing we have now is just a review app that creates this app. And the big problem originally was that there was no way to get to this review app. Trying to get AWS and the VPCs and everything to line up, exactly was not easy. But eventually we got that to work. So now you have this, and then it goes to a particular, right now he has it going to an environment which he hasn't set up yet. So he's got to change. The problem here is changing the Auto DevOps. You just can't make changes to the Auto DevOps include. And of course it's not working now. Why not? Hey, let me try that. Ha, that's funny. It's not working. So basically what'll happen is you change the thing, it'll fire it off. And I use my own Google domain that we can push to in the VPC and the test service, whatever it is, to map it. So you can see it's not customer ready at all, but they are working on it. And I believe the AWS Summit coming up will force them to make an investment to make this happen. Wish it was better news, but that's where we're at.
Just time check, Mark.
Okay, I'm done.
Okay.
Mark, is there an issue for this where we can follow along with the docs being developed?
Yeah, they're just setting that up between Orit
right.
and ATN, which is great. And Jason, there's a lot of eyes on it right now. And Caesar, product marketing group.
Thanks.
I'll start sharing.
Thank you so much, Mark.
You got it.
Amy, ready to take us home?
Yeah, you bet. Let me share my screen. All good? Everybody can see that?
Yep.
Great. So last but not least, a couple of new Terraform features in 13.0. First of which is GitLab's integrated HTTP Terraform state backend. And secondly, we've now got a merge request widget that provides a summary of your Terraform plan output directly within your merge request view. Our docs, thank you, kind of like Christian and Simon both mentioned, are pretty solid here. So if there's any product folks present or listening, thanks for an awesome job on that. And they really do a good job of covering the what and the how of infrastructure as code and all of these new Terraform things that we've brought to GitLab. So I'm going to focus more on the why, trying to mesh, what this is with how it fits with GitLab's value drivers and the conversations you're having with customers. First, the HTTP state backend for Terraform. So for the uninitiated, which is me, I've seen lots of talk about infrastructure as code. I thought I knew what Terraform was, but I'd never actually got my hands dirty. So I took this as an opportunity to try and learn something new. And again, the docs really helped here. So for those that aren't familiar, Terraform backends are what contains the state of your infrastructure. If you're not familiar with Terraform, it's a tool designed to allow you to declare what you'd like your infrastructure to be and to look like. And then it'll go through the process of, you can hit validate to sort of lint and check that your declaration is well formed. Then you do a Terraform plan, which compares what your declaration is versus what your infrastructure actually is. And apply tries to make the two match. And so the backend is really that stateful store of what actually is in production. By default, if you just download Terraform or install it and run it, it's going to use what they call the local backend, and that is just like .tf state files that are like binary stores of state on your local disk. That's all well and good, and it's fine if you're just a one-person team. But if you want to collaborate with others, having a shared store of state is really important to make sure that you're all singing the same tune. Likewise, the ability to lock that down while you're doing an apply, which can be kind of a multi-minute, quite a long process, depending on what you want your infrastructure to be and look like. Being able to lock that and say, listen, like I'm making a change, and everybody else that may be collaborating with me, please don't collaborate and step on my toes. So what have we actually done with GitLab? We baked in actually, I think that's the next slide, so I'm jumping ahead. For now, the technical tidbits here are that if you're a .com user, you really don't need to think about it, right? It just works, and I can show off where the HTTP endpoint exists and how that looks. If you're a self-managed customer, today the sort of technical tidbit is we use local storage, so it's like var opt GitLab something, where state is stored, and GitLab does encrypt that state. But you can also opt to use object storage, such as Amazon S3. Now the PowerPoint dad joke I've been waiting all morning to make here. I mentioned, and I wanted to give specific props to Nicholas Click, who's the EM in Configure, for really good documentation. And I've linked here to his example project, which really helped me get going from 0 to 100 real quick. So the takeaway here, really, if you think about nothing else, what to know when somebody asks you a question or when you're talking to a customer or prospect about this, we've baked in a secure, encrypted, and lockable store of state via HTTP into GitLab that follows both the authentication and the authorization models that are already in GitLab. So that helps really lower the barrier to entry for a team to adopt infrastructure as code or GitOps workflows and collaborate effectively. I'll talk a bit more about that as I get into the demo here, but the second sort of highlighted feature in 13.0 I wanted to cover was Terraform plan summary. So this is like a quick at-a-glance summary of any additions, changes, or removals you're making to your infrastructure as Terraform plan provides. But this appears directly in the merge request with a handy link out to the actual job that created that full Terraform plan output. We've actually gone a step farther, and we've created an inheritable or a customizable template as part of, just like the Auto DevOps build or test templates you can inherit. But you don't actually have to use it. You just have to sort of obey the artifact output here. And I've taken a screenshot of at least a piece of what that GitLab CI would look like. But it's the artifact reports Terraform object that the merge request looks for. And if that exists, and if it's well-formed JSON that it can parse, it'll show a quick, kind of one-line summary that I can hopefully show off here of exactly what Terraform has provided to you. Again, if you take nothing away other than this, the point is by giving our users immediate glanceable information directly in the MR, we're helping them deliver better software faster, or in this case, better infrastructure faster. And now for the fun part, the demo. So I've got a public project here that you are free to clone or fork or play with as you wish. Hopefully it'll work, but as Mark has shown, live demos are always a bit of fun. The joke here is it's always good to be more efficient when we're running up GitLab's GCP bill. So what the project here actually does is you can use it to spin up a Kubernetes cluster in GKE. So
Nicholas Click had a good example of using AWS and spinning up an EC2 instance inside of a defined VPC. I thought I'd try something of a different approach and one of the different cloud providers to provide folks kind of a different choice of examples depending on what you, your customer, or your prospect is interested in. So the project itself is pretty straightforward. There's a GitLab CI YAML here defined. We define the image. We're using the Terraform image, and actually all of this was I made pretty much a copy paste out of the template that I've linked in the slides. There's a before script that runs that actually defines an alias, and this is the alias that's used to convert the output of Terraform plan, remove any sensitive credentials, and then you can use that later on during the plan stage. Pardon me, the build stage. This is the plan job. Terraform will show the output of plan and then convert, you're piping it in to convert report, which is then writes a file in the container plan JSON, which the job passes out as an artifact. And that's what really triggers the magic in the merge request view. So the other stuff I'll show off relating to the HTTP state backend. So it's a pretty basic state backend. So it authenticates via the use of an API token. It looks very much like another API call. So if you've got a valid GitLab API token, you can do a curl, like an HTTP GET against your project ID, Terraform state, and then the project name. That should work. So this contains, in my case, this is version 4 of the Terraform's understanding of my infrastructure state. And there's a big pile of JSON here that describes, there's some resources, like there's a VPC in Google's compute network. There's a managed subnet. There's some Kubernetes details here, some node pool, et cetera, et cetera. This is all the information that Terraform uses to determine, what your declared state is and what the actual state of the infrastructure may be. Yeah, let me show off the MR widget, and then I think I'll yield to time in any Q&A. So maybe you've got a cluster up, but your boss is on your shoulder and says, "Hey, listen, you're costing me $500 a month for this Kubernetes cluster. You got to size it down." So in this case, here's an example MR to actually make a very basic change to the gke.tf file, which is where you're declaring your desired infrastructure. Previously, we had N1 standard 1 machines in the node pool, and you could maybe size it down to an E2 medium, which is like a lighter weight, less performant machine. Again, the point of a merge request is collaboration, right? So as a result of that potentially mergeable change in this branch, you can see here that the pipeline is run, was successful, and as a result, I've got a Terraform plan summary here. So very quick, it looks like 4 to add. So in the case of GKE and Kubernetes clusters in general, Terraform doesn't always necessarily provide the most meaningful sort of net delta, but there's also a handy link out here to the full output of Terraform plan, which, given some knowledge and experience, you'd probably be able to parse better than I. That would help you understand what are the changes that are actually being made here as part of this merge request. That's pretty much the summary. Any questions before we run out of time here? I see some activity in the doc. It looks like, Mark, you had a quick question here. Oh, yeah, it looks like I answered it. Good.
Yep. So is that widget, that happen automatically just by doing the report, or they have to push that in the team?
That'll happen. It's pretty much analogous to the same way like the JUnit XML or the code quality reporting works, as long as you specify that artifacts Terraform report object. So any job that passes that out, and provided it's JSON formatted, the MR will show that widget, provided that artifact has been created, and it'll parse it and give you that sort of changes, additions, deletions.
Okay.
I would imagine it requires a specific job name as well, right?
I don't think so. I think it's just the presence of
that's what I want.
The artifact. Okay.
The artifact, but I could be wrong. I don't think we're too opinionated about how the job is named. Like if we look at the, well, you know what? It's something we can experiment with here.
Have we used the
This
job
job
name
is
for
called,
anything else before? I don't think so.
Yeah, for code quality, security, all the SaaS, DAS, it
Oh.
had to have a specific job name and
Yep.
specific artifact name and format for it to appear in the merge request.
Artifact name I could see, but I guess I hadn't looked at the job names. They're just taking whatever the defaults are. So
let me take that offline. I'll try. I'll try renaming this from plan to something else, and I'll let you know. But that's a good thing to be aware of. Oh yeah, and sort of fun fact, it's becoming a tradition for me. Every time I'm asked to, or every time I volunteer to do like a release showcase, first thing I hit on this was a horrendous bug. So do not put any periods in the name of your project, because that if there's a period in the project slug, the Terraform backend just 404s. So I sat there for an hour wondering, what am I doing wrong? Like my Terraform backend doesn't work. And I've opened an issue. The engineering team is on it, but everything I try and demo, I just break. So product folks, beware.
Hey, Jamie, great presentation. I had the next question. I was wondering, our configure team, they implement Auto DevOps and review apps. I don't think that they make use of like, Terraform or infrastructure as code tools. So I wonder, does it make sense to try to re-implement the review apps feature, like just the whole provisioning of the environments? Does it make sense to implement that in Terraform? Do you see any issues with that in terms of how that would work?
Yeah, I mean, it's an interesting question. I think you could easily sort of roll your own sort of review app-esque pipeline where like you say, you use Terraform to define sort of a short-lived, review app environment that only exists for the duration of the MR being open. I think in the case of review apps today, there's probably not much that actually changes from an infrastructure perspective, right? Like you really just you're making an ingress change, which is probably a bit sort of below the, or maybe above the layer of Terraform. So if you think of what Terraform is like in the case of Kubernetes managing, what zones or regions should your cluster be in, what size of node you want to use. It's not to say you couldn't do that with Terraform, and maybe if there's any folks in the call that have expertise in Terraform would state an opinion like, oh yeah, you could definitely manage that in Terraform and make that change in Terraform. Today, how do we do it? We just pass a change to the ingress, like the Nginx ingress chart, right? To turn up like a specific sort of review app domain name.
Yeah, I think like from the last time I read through it, it's like there's a specific job that spins up, I guess that does that deployment, that ingress service deploy and all those other components. I was just wondering if there are any plans to try to re-implement that using Terraform tools. But yeah, I think what you said makes sense, is that the nature of the change is not that dramatic. It's just, you're just spinning up a temporary environment. It's probably just the same deploy every time. But
love the question, and I think it'd be interesting to see how we evolve in this way, right? Like I asked the question in one of my last slides there. I think the combination of like infrastructure as code and how we evolve there, plus what we're doing with releases and release evidence, I think that's going to be really neat to see how those play together. I know we're at time, so I'll yield back to Chris, but thanks for the question.
Thanks to all our presenters today. I know Simon and Christian had to drop off, but big thanks to them, to Chloe, Mark, and Jamie. Thanks to John Woods for the idea to kind of have a separate focus area on this versus just doing it in the all hands. Really appreciate the support. Great questions. We will see you all next week.